My name is Graeme Rocher. I'm the creator of a couple of well-known frameworks in the Java space. One of them is Grails, which has been around for a lot longer. And the other one more recently is Micronaut. I'm an architect at Oracle Labs. I won an Oracle Groundbreaker Award a few years ago. I'm a Java champion alumni. And I'm currently leading Oracle's contributions to Micronaut. Micronaut is really a multi-organization project nowadays, with committees from object computing, from Oracle, and we have contributions from Google, for example, in the GCP project. It's really grown into a kind of multi-vendor effort. And you can connect with me on various social networks down there. So like I said, on the agenda today, we're going to do a brief introduction to Micronaut, an introduction to GRAALVM, and we're going to do lots of demos, and then we'll have time for Q&A at the end. So what is Micronaut? Micronaut is, you can essentially think of as a build time framework. Much like frameworks like Spring and CDI rely on runtime configuration or wiring to your application together at runtime, Micronaut does everything at build time. So during your compilation process, it actually hooks into your compiler. It does this differently depending on the language you're using. So for Java, for example, it uses annotation processes to hook into Java-C. And it computes things like dependency injection, configuration injection, all of your annotation metadata. So like if you declare annotations on your classes in the framework, Micronaut never references those directly. It actually computes the meta time to work out how to wire together your application. It doesn't rely on any kind of runtime bytecode generation library like ByteBuddy or Java Assist or CGlib to generate proxies for AOP, aspect-oriented programming. So when you have like method interceptors, the most famous one is probably @transactional. When you have like @transactional on a method, for example, Micronaut doesn't do anything at runtime to proxy your classes. That all happens at build time. It also has replacements for common APIs that use reflection. So commonly used in reflective activity is java.beans.introspector to get the different properties of a Java bean and conform to Java bean conventions. Micronaut has its own abstraction over introspecting beans that works great in a variety of different scenarios. It works great with regular Java beans, but it also works great with, for example, you just had a session on Kotlin, so Kotlin data classes. It works great with Java records, and it works at compilation time without using reflection. So what bean introspections allow you to undertake tasks like serializing an object to JSON or deserializing object from JSON, or reading an object from the database, or writing an object to the database without using any reflection whatsoever. So Micronaut is completely reflection, runtime proxy, and also dynamic class loader free. And this makes a big difference to the developer experience in a number of different ways. One, you don't get these like massive stack traces so much in Micronaut because without the use of reflection and runtime proxies, the stack traces are much smaller, easier to debug. Micronaut starts up a lot faster and executes your code. So integration tests often feel like unit tests because it's so fast to execute tests. And the lack of dynamic class loading means that Micronaut is just using the system class loader, which means you never run into problems, weird issues with class loader issues or class loader hierarchies. It's just a much simpler runtime architecture, which is reflected in the size of the executable that you build as well, which is like 10 megabytes. So you can think that Micronaut is more complex at build time and much, much simpler at runtime than other frameworks of its ilk. So with Micronaut, you can build a variety of things. You can build microservices, clearly, as the name may suggest, but you can also build serverless applications. We have great support for serverless, so you can build things like Lambdas for AWS or Oracle functions, deploy to Oracle function, or you can deploy it to Google Cloud Run. And it's really multi-cloud in that sense. And you can also build message-driven applications. So we have great support for messaging frameworks and messaging systems. We have great support for things like Kafka, RabbitMQ, JMS more recently, and even on IoT devices, we have great support for MQTT. And you can also build command line applications. So it's a common use case to build CLI apps with Micronaut because it starts up fast. It's a good fit for CLI applications. And we even have it operational on Android, so you can build mobile applications and use Micronaut to dependency injector on Android. So pretty much anything that has a static void main entry point, you can use Micronaut for. It's not it's kind of a general purpose framework. And we currently support, because it's build time, we currently support 3 different languages. We have to plug in differently to the compilation process of those different languages. We support Java. You just had a session on Kotlin, so we have a very engaged Kotlin user base and great Kotlin support. We have direct integration with Kotlin in a number of different ways, as well as modules that extend support for Kotlin. And we have a website for creating applications called Micronaut Launch, and I believe that 30% of the applications created through that today are Kotlin applications. So, definitely a vibrant Kotlin community around Micronaut as well. And we also support the Groovy language. So the Groovy language is more dynamic language, and we have great support for Groovy, and even support for certain frameworks and tools from Grails like GRAALVM and so forth to make Groovy users feel at home. So what is GRAALVM? GRAALVM is essentially a new virtual machine out of Oracle Labs, which is where I work, and it's able to increase your application throughput in JIT mode. So you can plug into the JIT compiler and replace the existing JIT and reduce latency in your application by between 20 and 30%. It's also able to build completely self-contained native images from a Java application using what's called closed world static analysis. And this is the feature that's getting Java developers really excited, because you can build native executables with Java, which opens up a world of possibilities that are not possible with the JVM, which is a clearly interpreted code. So you can run applications in places where don't allow that. They even have GRAALVM working on, for example, iOS, which is incredible. And you can essentially optimize your startup and execution and memory consumption significantly by building a native image. And this is great for cloud deployments. It's great for serverless. And it means you can run more instances of your app on fewer resources. And is really a pretty compelling feature of GRAALVM that's growing rapidly, and Micronaut has great support for. GRAALVM also has a language framework called Truffle, and it has a number of implementations of different languages. In fact, the default implementation of JavaScript is now provided by GRAALVM and the JDK. And there's implementations for Ruby and Python and different languages, and even a new implementation for Java where you can essentially interpret Java on top of Truffle, which has some interesting possibilities for the future. So it allows the seamless interoperability between different languages. Ruby can invoke Java, and Java can invoke Python, and Python can invoke JavaScript or whatever without any overhead. So GRAALVM is really many things to many different people, and depending what you're doing with it, it's a variety of different things. It's kind of grown people have grown in awareness of it through native image, but it's really a compelling tool suite of different things that's really driving innovation in Java. And Micronaut works great with GRAALVM, so the two frameworks fit really well together, particularly with native image, because essentially when GRAALVM does the closed world static analysis on your application to identify and turn it into a native image, it needs to be able to do a complete closed world static analysis. And if your application does anything dynamic, you need to tell GraalVM native image about those dynamic uses. So dynamic things are like dynamic class loading, reflection, usage of runtime proxies, bytecode generation, dynamic class loading, etc. So you need to configure GraalVM for all those different use cases. And because Micronaut doesn't do any of those things, it makes it a great fit because there's just a lot less work for the tool to do when converting a Micronaut application to a native image compared to using native image with other frameworks or tools. And once you convert your Micronaut application, HTTP application, into a native image, the results can be spectacular. So like startup time is orders of magnitude faster. It drops to like 20 milliseconds, and memory consumption drops to 18 megabyte, which is just remarkable. So and makes it possible to deploy Micronaut plus GraalVM in places where Java maybe wasn't really appropriate, such as serverless or on IoT devices and so forth. So there's really a compelling movement around Micronaut and GraalVM and other frameworks that are GraalVM friendly, and that's going to continue for the next few years. So with that, I'm going to start actually doing some live demoing and go take you through a demo of using Micronaut. And hopefully you can see a little bit about what it's about. The rest of my session is completely live coding and demos, so hopefully we'll have a lot of fun. Okay, so there's a number of different ways in which you can create a Micronaut application and get started using Micronaut. One way is we have a command line utility called MN. And MN lets you create Micronaut applications completely offline, locally, when you don't have internet connection or whatever. Now, the interesting thing about MN and the Micronaut CLI is that it's actually a Micronaut application itself. So we're kind of eating our own dog food, if you like, in that we built the Micronaut command line with Micronaut itself and computed it into a native image that runs on your specific platform. So we have native images that are built for the Mac, we have native images that are built for Linux, and native images that are built for Windows of MN. So the Micronaut starter project is a great sample application because it's an example of building different executables for different platforms with GraalVM. And the other thing that MN is it's a website. So we take the same application, the same command line application, and we run it as a serverless application online. So you can go to micronaut.io and click generate a project, and you come to this application generator, and the backend is running as a serverless application. So if you want another example of a serverless application, it's good to look at the Micronaut starter source code. So you can go to Micronaut project, Micronaut starter, and the source code for the Micronaut command line that I'm using in these demos, and the backend, serverless backend for this website to generate applications is all here, and you can learn on exactly how it works. We actually continuously deploy this application to a number of serverless platforms, including Lambda and Oracle Function and Google Cloud Function, to verify that it works on all the different serverless platforms and so forth. But fundamentally, this is a project generator, so you can select your type of application. So we allow generating different applications to different shapes. So you can have a Micronaut application, which is just like a REST application, but you can also generate a command line app, serverless app, gRPC, and a message-driven application, which changes slightly the structure of the app. You can also choose your Java version, the base package, any kind of Micronaut version that you are interested in, and basically the language you're interested in using, and your build tools. So we have support for Gradle, and the Kotlin DSL, and Maven, and your test framework. So we support JUnit, Spot, and Cotest. And then you can go off and add features. For example, you can add support for data JDBC, and basically that will add an additional feature to the generated project. once you've added additional features, you can actually click the diff button, which will show you the diff of what happens when you add that feature. So you can see that when I add Micronaut data JDBC, it adds some extra dependencies around JDBC and an extra configuration and so forth. You can also click the preview button to preview what's going to be generated, which is pretty cool. And so yeah, if I switch to Maven, for example, and click preview, it'll generate a POM file instead of a build.gradle. Once you're done, you can click generate project and either push the project to GitHub directly or download as a file. So that's Micronaut launched online. And like I said, you can do the same thing with MN locally offline, where you can actually create your app locally, and you can select the name of the app, and you can choose your features. I mean, you have like code completion for the different features that are available, and generate an application locally. In addition to that, all modern tooling, like the latest version in IntelliJ, have integration with Micronaut Launch to generate applications, and also so does Visual Studio Code. So I have a Visual Studio Code set up here, and what you have to do with Visual Studio Code is you have to have the GRAALVM extension pack installed. So I have it here. The GRAALVM extension pack comes with GRAALVM, Micronaut extension, and the actually NetBeans language server. And what you can then do is you can say Micronaut, create my new project, and select your Micronaut version. And this is again working with the backend Micronaut, your GRAALVM, local GRAALVM installation, the name of the application, which I'll just leave as demo, the package, your language, and then you can pick the features that you want to include. So I'm going to say Micronaut data JDBC, and you can pick your build tool, your test framework, and then it will generate into the directory you're interested in. So I'm going to say Java, particularly in my JavaDay. And then it will open up, and here is my new application that was just imported. So this is the Micronaut application, and Micronaut application essentially has a application class, much like Spring Boot, where you can run the application as kind of like the main entry point. Once you import into VS Code, you should run the quick fix to resolve the project problems, which will just essentially download all the dependencies needed to navigate around this project and so forth. There we go. So now my application is imported, and now you can click navigate and so forth around the application. So this is how you basically run your application. So I can directly run this application directly from VS Code, and Micronaut, when you create an app, also creates an initial test. So here I have a demo test that basically just asserts that when you run the test, that the application can start up successfully. So I can run this test, and my application is up and running. Now, one thing to note that this is a full-on integration test that I'm executing here. And test execution in Micronaut is just like super fast. It's like really fast to execute tests and run tests locally. And some of the interesting things is that if we drop into terminal, for example, you can use Gradle run /t, and also I would recommend adding watch file system. And then you can get some nice automatic reloading for when you make changes locally and modifications to your application. So if I add like a print line here, and like so, and then I save this, the application will automatically detect those changes and restart, and you get automatic hot reloading as your application restarts automatically for you. Okay, so and that can be achieved by just dropping into terminal and starting Micronaut in a predefined way that you're interested in. Okay, so in addition to that, if you want to build a runnable WAR file, you can just assemble the application. I'm using Gradle here, but if you chose Maven, it's essentially the same thing. You can just do jar and run the application locally, and that's it. The application starts up. It's actually using setting up an in-memory database and high carry and connection pool. That's because I chose Micronaut JDBC as a feature when I created my application. But creating a runnable jar file is really simple, as is building a Docker image. So I can just say Gradle W Docker build, which will build my application using Docker and allow me to run it on Docker automatically out of the box. And we by default build layered Docker jars and automatically and all those kinds of things. So that is getting quickly started with Micronaut. Now let's go on to Micronaut dependency injection. So essentially, Micronaut is based on dependency injection. So for example, if I were to create a pet.java class here under package example, and this is my pet, and maybe it has a private string name, something like that. And actually, packages com.example. That was a mistake. Okay, and then I can generate a getter and setter for it. So that's like a pet class that may represent some entity in my project, and then maybe I'll have a pet service .java like so. It again sits in my package com.example, and this is going to be my pet service like so. Just going to check that nobody has any problems. Okay. Right, so this is going to be my pet service, and maybe it's going to list some pets, list pets like so. And we're just going to, I think we probably have to import java.util.list, and then we're going to turn arrays as list, like so. Import java.util.arrays, and we're going to have let's add a constructor to create a new pet based on generate constructor. There we go. So we can generate a constructor for my pet, and so maybe we have Fred, and we have Bob, like so. And so that's basically some kind of pet service, right? So the only thing you have to do to make this component available for dependency injection is to annotate it with @singleton or any scope that you want. So Micronaut fully supports JSON 330, which is the Java inject specification. So you can add any scope onto a component, and that'll automatically make it available for dependency injection. So then you can create, like, for example, some kind of well, let's create a test in here. Let's say let's call it pet service test, like so. And again, in my package com/example, and this is going to be a pet service test, right? And Micronaut has a built-in dependency injection framework, a built-in testing framework called Micronaut test. So you can just add Micronaut test to any JUnit5 test, and then you can use inject pet service, because my pet service is available for dependency injection. And again, you can see I'm using JavaX to inject right here, and basically, write whatever do assertions, set equals, and do to pet service list pets.size. Something along those lines, just to verify that dependency injection is working as I expect. So when I run this test, you'll see that the test passes correctly. I think probably you have to switch the debug console to see the output. Basically, the test passes correctly. And as you can see, in this case, we're using what's called field injection. So I'm injecting pet service into my my test. But you can also do constructor injection. So, for example, I can make this final, and I can go to my source actions and generate a constructor for my pet service and inject it directly into the constructor of my test, and that works well as well. You know, in general, you want to encourage immutability in your code. It makes it easier to reason about code and rationalize about it. But as you can see, Micronaut has built-in support for dependency injecting different components into each other using javax.inject. Now, in this case, I'm like hard coding the different pets that are like available directly into here. But you may want to drive that by configuration, and a great way to do that is, you know, by configuration properties. So Micronaut has, you know, great support for configuration properties and configuration injection. So I can create like a pet configuration class, like so, and this is maybe a pet configuration. And Micronaut has very nice support for configuration properties in different ways. For example, you can say configuration properties and bind this to a pets configuration that you define in your application.yaml file here. But another nice way is to allow like multiple configurations. So, and that can be done with each property. So I can say each property name pets, which is what I'm going to do. And maybe you have like the name of the pet, and you have maybe we add an age property, for example. Create some getters and setters for those. In more recent versions of Micronaut, we allow also interfaces instead of classes. So you can just define the getters. And we also, in the latest version of Micronaut, support records for Java records, which are Java 14 plus records for defining configuration properties, which makes it a lot easier, more concise, that is, than having all those getters and setters. You can, of course, also involve Lombok if you wanted, but basically there are ways, to either using interfaces or records, or if you're using Kotlin data classes, to make all of this a lot more concise if you want to. So that's basically a configuration property that we have. And then what you can do is maybe do something like, let's see, let's add a private final int age here. Let's make that final. Let's remove this setter, and let's generate a new constructor in this. So I'm going to do source actions, generate constructor. And let's click back. There we go. So now we have a constructor for that. So my class is immutable, and we generate some kind of getter for my age. So there we go. So I have a pet class, and then in this pet configuration, maybe you can add a pet create method that takes the configuration and passes in the name and the age. Now, the cool thing is that with Micronaut's configuration properties and configuration injection, you can apply validation rules. For example, I can say, using javax.validation, that shouldn't be blank, and that the minimum age of a pet, or maybe minimum age of the pet is 1 or something like that. So you can validate these, and Micronaut will at startup make sure that these are correctly validated. And then when in this create method, you're making sure you're creating valid versions of pets. I can then create like dependency inject those pet configurations into my class here, and once again use source action, generate constructor, generate my pet configuration, and basically do something like, let's see, pets stream map pet configuration create select something like collectors to list. There you go. So so now we have my actual the definition of my pets being powered by configuration. So I can come in here and say pets. Let's go Fred, name Fred, age 10 or 8, Bob, name Bob, yeah, maybe the name's not complete, age 6, something like that. And we have this control over, the creation of pet configurations via my configuration properties in my environments. So if all goes according to plan, which hopefully it does, this should pass. And it does. So, if I were to add another pet in here, maybe Joe, name Joe, and then don't correct that, age 2, and run that again, you can see that probably this time the test will fail because there's actually like 3 pets now instead of 2. Also, if you try and create like a pet that's invalid or something like that, then once again that will fail validation rules and the test won't pass. So there's various ways in which to ensure that your configuration is valid in Micronaut using dependency injection and so forth. So that's a nice little demo of dependency injection and configuration injection. I'm actually ahead of my demo. And then Micronaut has built-in support for aspect-oriented programming. Oops, I keep switching back to that window. So you can, why is my VS Code not appearing? Oh, there we go. Okay, so AOP and Micronaut is really simple. You can, for example, just create a method interceptor. So I can say like logged interceptor, for example, interceptor.java. And this once again can be package com.example and class logged interceptor. And this we're going to be implement method interceptor like so. And method interceptor takes a couple of generic arguments, which is like the return type and so forth. You can source actions, generate implement method intercept. There we go. So a method interceptor basically intercepts a method invocation, and there's a single method that you can implement called intercept, which gets passed a context object. So you can say context.proceed to just proceed with the invocation. Now, what you want to do as well is make sure your interceptor has a particular scope to use Micronaut aspect-oriented programming. So I'm going to make this a singleton. This particular interceptor has no state, so it's a good candidate for just being a singleton that's shared amongst multiple different interceptors. And what you can do is, I'm just going to, as for the purposes of demoing this, I'm going to write the method name of and just do context.get method name. And there we go. So it's going to output that. And then what you want to do is essentially create an annotation that triggers this interceptor. So you just create a log.java, and it's going to be in package.com.example. And this is going to be a annotation. So it's going to start at logged. And then you want to add like the retention policy. So retention policy runtime to the annotation runtime. Like so, you probably want to target the annotation just to and type methods, I imagine. And then to make it Micronaut AOP advice, you just apply the around annotation. So around advice in Micronaut signifies that this wraps a method call invocation. So you just annotate with the add around. And then you want to link it to a particular type of interceptor types. I'm just going to add the type of the interceptor and add that in there. You can then come to any method call and, for example, this list pets method, and you can add at logged on the method call, and essentially it will apply that AOP advice to that method. For example, if we go back to my pet service test, and that's just going to run. So let me set a breakpoint here, like so. I'm going to set a breakpoint, and now it's actually debugging my test. And you can see my log method interceptor gets hit in my debugging, and when it'll essentially stops on that breakpoint, and the interceptor is being applied to my pet service, and you can of course do whatever you want within that logic. In this case, I'm just printing the method line, but you could apply validation, you could apply just tracing, you can do all sorts of things here. The context object actually allows you to get hold of the parameters, values, for example, as an object array or as a named object map. You can get hold of the argument types and also all the annotation information. So you can get hold of all the annotations on the context and basically customize exactly how you want to log. For example, you might have something on the log application where you have like some kind of enum level, and you have like trace, debug, info, or whatever, and then it has some kind of level value, or the default being debug or info or something like that, maybe debug. And be something like that. And then within your logged interceptor, you can say, give me the enum value for the logged annotation, and I want it to be enum value. It's going to be here. So logged, we want logged, and the enum type, which is going to be level, class, or else level, debug, etc. And maybe you can alter how you output that, based on the annotation metadata available to you from the invocation context. So the invocation context provides you with all sorts of annotation metadata. You might be wondering why can't I just use like the annotation? So Micronaut provides an abstraction over this. All the annotation metadata is captured within the method invocation context, so that you don't have to use reflection to essentially look into that and do something with it. So that's Micronaut AOP advice. It's really pretty powerful and flexible. Let's carry on with the demo. So now let's look at Micronaut events. Micronaut has built-in support for events and an like event-like behavior. So, for example, I don't know, you might have a new file, list pets event.java under the com.example package, and it's going to be list pets event, something like that. And maybe it has a final list of pets. And then you have source action, generate constructor, like so. I don't know why that's any. Hold on, probably because I missed this import. Okay, so list. Like so, that's my event class, and maybe we generate a getter to get hold of the pets. And maybe we'll just do it inside this interceptor. For example, you could define the application event or the application event publisher, like so, and you can generate a constructor for that, like so. So we inject the event publisher into my interceptor here, and maybe we can essentially get hold of the return value of the method result, and if result instance of list or something, this is a very contrived example, so it's probably a better example I could come up with. But anyway, yes. Okay, so let's do that. This would probably fail in real world with a horrible class cast exception or something like that. But it's a very contrived example. You probably wouldn't do this, but you can do it. Publish event, new list pets event, like so, and we can publish that event out somewhere. So every time this AOP advice is triggered, it's going to publish an event and then return the result. Then somewhere else in your application, you can, for example, I might make my application class itself a bean. You can basically have on list pet, list pets event, like so. And you can mark this as event listener. And basically every time the list events event is triggered, you get these in-memory events. So list pets event, like so. Okay, so we got all the pets. We got a semicolon needed, right? Okay, so if I set a breakpoint here, and once again run my pet service test, like so. Actually, I didn't. I think I just ran it and debug it. You see, my breakpoint is hit with my list pets event. So you can have these decoupled event system through the application event listers and event publishers. The cool thing is, of course, you can make this event asynchronous by just adding async so that it doesn't block the event publisher, and all sorts of things. So the event system for in-memory events in Micronaut is very powerful. So far we haven't done anything around HTTP. Or just keeps changing. But basically, Micronaut has a comprehensive HTTP layer. So you can, create, for example, here a pet controller.java, and again within the com.example package, and it can be a pet controller. like so. And it's essentially a controller that maps to the pets endpoint. You can add your get action and map it to there, and then you can list all those pets like so, and expose it via HTTP. Then you can inject your private final pet service like so, and generate a new constructor for it like so, and then call our return pet service list pets, and we have exposed that of HTTP and JSON. And then you can come in here and you can write a new pet controller test .java, which again exists in the com.example package. It can be a pet controller test like so, and this can be again a Micronaut test, and Micronaut has built-in support for decorative clients, so I can say interface pet client like so, and we can just copy this signature and stick it in there, and we want to import that, and we want to import that, and there we go. And then we have this being a client of the pet endpoint like so. Then we can inject the pet client into my test and write a test here that is an integration test. And we can say assertions set equals. Let's first do. Hold on. Let's first do pet client list like so. Introduce a variable and say so the list is of size 2. So that's a simple controller and a client that invokes it using Micronauts built-in HTTP facilities, which fails for some reason. Valid definition exception. Okay, so this is one difference. Right now, Jackson is trying to serialize and deserialize this, and it cannot because it doesn't know how to, because it's got a constructor and it's not valid. Micronaut has nice integration with Jackson. You can add app introspector to this class, and it will give Jackson additional awareness of how to construct this object, and it will also essentially plug into Jackson so it can serialize and deserialize objects without using reflection. So with this magic annotation introspected on your class, you get reflection-free JSON serialization and deserialization. So I can come back to my controller test. I don't know why it's still hanging around. Run it again, and hopefully this time it will pass, and Jackson will be able to deserialize and deserialize, which it can. And this deserialization and deserialization is completely reflection-free. So that is Micronaut's HTTP layer. And the last thing I want to demonstrate to you is Micronaut data. Micronaut data is, I don't know why I cannot switch to, anyway. Micronaut data is a database access toolkit. And all you have to do is add this, make this, for example, a mapped entity to map to a particular database. In this case, we have already pre-configured H2. Then I can come to my pet service and I can make this an interface. And this is going to be a JDBC repository that's going to use the JDBC repository. It's going to use the dialect. Oops. Dialect page 2, like so. And we can make this extend code repository and pass in pet and ID type. Now one thing that I realized with this is that I don't have an ID type on my pet. So we need to add one. So I'm going to add a private long ID like so, and we're going to make this a generated value. And it's going to be the ID for my entity, and then we're going to say generate a getter and setter for that. That's going to be my database ID on my entity. We can optimize those imports like so. Then in my pet controller, we don't actually have a list pets method. You can use find all, which is part of code repository. The only thing is that method actually returns an iterable. So I can source action, generate override, find all. I can actually override that method and then make it return a list like so. And that's all you need to integrate with Micronaut data. Now, the only thing is in my pet configuration, I believe, I was previously reading things from the database, reading from my pet configuration and creating these guys. So what you could do essentially is do that separately. So I come into my application class somewhere, application class, and maybe I could inject my pet service and also inject my list of pet configurations. Like so, and then come in here and generate a constructor. For that, no, why do I always forget to import that? Oh, that's a pain. Okay, so there we go, a list of pet configurations. And
Graeme, I'm sorry. I'm sorry that interrupt you.
That listens for the startup events. So when Micronaut starts up, and you can make this transactional. We support JavaX.transactional, and you can say, pet configurations for each config, something like that. Pet service.save. It would probably be better to do a batch save all, but anyway, for this demo, I'm gonna create the pet. That could probably be a lambda. Okay, so that's going to actually, when my application starts up, it's going to go through all the configurations and save them to the database using the pet service. Basically my application should behave exactly the same. This should be find all. If I run this pet service test, there should still be two records that get saved from my pet service, which is the test process. So now we actually have a full database application going back and forth between using Micronaut data. And obviously, Micronaut data is a lot more powerful than just doing list and find all. There's on CRUD repository itself, there's save, update all the CRUD operations. But you can also add methods that find a pet by a particular name, like so, and it will generate the appropriate query period compilation time. Now, the nice thing about Micronaut as well is because everything's compilation time, we do a lot of compilation time checking. So, for example, if I were to misspell this, find by nom or some ridiculous thing, you'll see that you get an error, right in the IDE. Unable to implement repository method, find by nom, cannot query pet entity or non-existent property nom. So we have built-in checking and compilation checking of your application.
Hey, Graeme, sorry to
and
interrupt you.
that happens at compilation time.
We
Like if I try to run my
out of
application
time.
or run my test again here,
Could you please switch to the Q&A
you will see
session?
that it will actually fail compilation with the appropriate error. Okay, so that's the demo. Apart from the native image part. So if you want to build a native image, basically what you have to do is come into your terminal and you say GRAALVM native image, and we have equivalent commands for Maven if you're using Maven, and that will start building your native image. Now, building the native image actually takes a little bit of time. Actually, I need to fix that compilation error. So I'm going to leave the native image building for a minute, and we'll come back to that. I'll just do a quick summary because I want to have time for Q&A, and after the summary, we'll go back and look at the native image. But basically, you can build Micronaut provides an awesome foundation for your applications. It has lots of different features, and all of them work at compilation time. Whatever you do with Micronaut is fully compatible with GRAALVM native image out of the box, because what we produce at compilation time is essentially free of reflection, or free of dynamic class loading, free of bytecode generation at runtime, free of anything that would require extra configuration to use native image with Micronaut. So it has really strong integration with native image. And it's flexible enough to be used in a range of different scenarios beyond microservices, right? So you can use it for CLI apps, as described. You can use it for, message-driven microservices, IoT, and there's so many different places. It's not just an HTTP. The key thing is it's not just an HTTP framework, right? It's much more than that. So let's have a look how my native image is still building. So this process is basically will take some time. It's basically doing a closed world static analysis of the application, looking at all the places that it needs to look at, and producing. It's progressing now, and producing a essentially self-contained native binary. So we have within the Gradle plugin for Micronaut built-in support for building native images. I'm building a native image that's actually for this machine, so the native image will actually only work on the Mac. But we also have support for building native images as part of the Micronaut Gradle plugin and the Micronaut Maven plugin, building native images for using Docker. So if you're using building for a particular platform or Docker container environment, we also have great support for that. And yeah, there's we also have support for building native images in a number of different scenarios where they're really beneficial. For example, we have support for building native images for specific support for Oracle function and AWS Lambda. So there you go. The native image was built, which you can then run with build native image application. And you can see that even this is involving a database and everything else. Startup time locally is 52 milliseconds. It was writing to the database on startup and so forth, but it's still pretty fast. So some resources. There's the Git community around Micronaut framework to come talk to us. We have great documentation. There's Micronaut launch for creating apps. There's a lot of guides. Do follow us on Twitter. Also, do start a repository on GitHub. We would love to hear from you. Do star us, do follow us, and get involved. And with that, hopefully have some time for Q&A.